So if you are, hunting for a mid-century home and your inspector finds aluminum wiring, it usually just kills the deal instantly.
Oh, yeah,
Right.
completely. Buyers just panic and run.
Right. They run. But today we're looking at a stack of official data and insurance guidelines that prove this terrifying hazard doesn't actually have to be a deal breaker.
No, it really doesn't.
In fact, if you understand the science behind it, finding aluminum wiring might just be like your best negotiation tactic.
Because knowledge is leverage, right? I mean, when you understand the specific mechanical risk and, more importantly, how it's permanently mitigated, you move from this emotional reaction to a strategic one.
Exactly. And we have a massive stack of sources custom tailored just for you today for this deep dive. We're looking at real estate guides, electrical inspection reports, insurance agency blogs, and data straight from the Consumer Product Safety Commission.
The CPSC.
Right, the CPSC. And I like to think of aluminum wiring like an aging roof or an outdated HVAC system. It is a significant capital expense. Absolutely. You have to factor it into the home's valuation.
Oh, for sure. It's an expense.
But it doesn't mean the house is going to, spontaneously combust tomorrow.
No, not at all.
So to understand how to negotiate or fix the problem, we first need to look at why builders even put this metal in the walls to begin with.
Yeah. The origin of this wiring really just comes down to mid-century economics and geopolitics.
Geopolitics?
Yeah, we are looking at a very specific window here, from the mid-1960s to the early 1970s.
Yeah,
Copper was, and I mean it still is, the gold standard for electrical wiring.
because it's a fantastic, stable conductor.
Exactly. But during that specific era, the copper supply became incredibly scarce and just prohibitively expensive.
Right, and looking at the historical context from the sources, that scarcity was directly tied to the Vietnam War.
Oh, absolutely.
Because copper is essential for military munitions. I mean, everything from millions of shell casings to the wiring in tactical vehicles, communication networks.
The defense demands were just gobbling up the national supply.
Yeah. And at the same time, the post-war housing boom was, still pushing forward. Home builders desperately needed a cheaper, readily available alternative to wire standard 15 and 20 amp residential circuits.
And aluminum fit that bill perfectly. I mean, it was cheap, it was highly flexible, and it was abundant. So the housing industry pivoted rapidly.
Very rapidly.
Yeah. Estimates show roughly 2 million homes across the United States were built using single-strand aluminum wiring during that 10-year span.
Wow. 2 million homes is a massive footprint.
It's huge.
And the statistics regarding the danger are pretty sobering. According to the CPSC surveys, homes wired with this pre-1972 old technology aluminum wiring are 55 times more likely to reach fire hazard conditions at their connection points.
55 times.
Yeah, 55 times compared to homes wired with standard copper.
And, that 55 times multiplier isn't just some theoretical safety model. The CPSC significantly ramped up their investigations after a really tragic incident on April 28, 1974.
Right, the Hampton Bays fire.
Exactly. A house fire in Hampton Bays, New York, killed 2 people, and fire officials traced the exact cause back to a faulty aluminum wire connection at a single wall outlet.
Just one outlet.
Just one. And that fire really put aluminum wiring on the map as a severe national safety hazard.
But what's fascinating looking at the engineering reports here is that the wire itself, like the long run of bare aluminum sitting inside your drywall, isn't actually the hazard.
No, it's not the wire itself at all.
Right. The failure is entirely localized to the connections. The points where the bare aluminum physically attaches to a switch or a wall outlet or, another wire in a junction box.
Yeah, because aluminum behaves fundamentally differently than copper under an electrical load, specifically regarding, thermal expansion.
So break that down for us. What does thermal expansion actually look like inside the wall?
So when electricity flows through a wire to power an appliance, it naturally generates heat. Now, copper expands a tiny bit under that heat, but aluminum expands significantly.
Okay, so it swells up.
Right. And then when you turn the appliance off, the current stops, the wire cools, and it contracts back down.
So it's swelling and shrinking constantly.
Day after day, year after year. And that causes the aluminum wire to slowly creep out from under the tiny terminal screws holding it in place. The physical connection simply becomes loose.
Wow. And a loose connection introduces the second major metallurgical factor, which is oxidation.
Yes, the dreaded oxidation.
Right, because every metal rusts or oxidizes when exposed to oxygen. When copper oxidizes, the resulting copper oxide still conducts electricity efficiently.
Doesn't stop the flow.
Exactly. But when aluminum oxidizes, it forms aluminum oxide, which is an electrical insulator.
Right. It actively blocks the flow of electricity.
And there's a third factor that makes that whole oxidation cycle even worse, right?
Yeah, because aluminum is a relatively soft metal compared to copper, it suffers from a phenomenon known as cold creep.
Cold creep, that sounds terrible.
It is, mechanically speaking. When you tighten a steel screw down onto an aluminum wire, the constant pressure actually causes the soft metal to deform and flow out of the way over time.
Like it just squishes away from the pressure.
Exactly. It yields to the pressure, creating even more micro gaps for oxygen to enter. Plus, because it's so soft, it's really easily nicked or compromised by the electrician's stripping tool during the initial home installation.
One of the engineering blogs visualized this perfectly, and I loved this analogy. They said it's not a flow problem, it's a friction problem.
Oh, I like that.
Yeah. Think of electricity like water in a hose. Copper is a wide open hose. But an oxidized, loose aluminum connection is like putting a severe kink in that hose.
Right, the pressure builds up.
The electrical current struggles to push through that narrow, highly resistant gap, and all that electrical friction generates intense, concentrated heat right at the outlet.
And eventually, that resistance gets so high that the electricity starts arcing.
Literally sparking across the gaps.
Yes, literally sparking across microscopic gaps.
Yeah.
And that arcing creates temperatures high enough to melt the plastic wire casing, melt the outlet faceplate, and ignite the wooden studs inside the wall.
Because the heat simply has nowhere else to dissipate.
Exactly.
But wait, if this wiring is 55 times more likely to cause a fire and is doing all this intense swelling and arcing inside the walls, shouldn't half the houses built in 1970 have burned down by now?
You'd think so, right?
Yeah, I mean, why isn't this degradation more obvious to the homeowner?
Well, the terrifying truth is that this degradation process is often completely silent and invisible.
Invisible.
Yeah, it happens entirely behind the wall plate. A connection can reach fire hazard temperatures without ever giving a symptom you'd notice from the living room couch.
Though, to be fair, the CPSC notes there are sometimes warning signs if you know exactly what to look for.
True. There are subtle clues.
Like, flickering lights that aren't caused by a dying bulb, a light switch faceplate that feels unusually warm to the touch,
Warm plates are a big red flag.
or circuit breakers tripping for no obvious reason. Even weird static interference on your radio or television.
Yeah, but the most urgent sign is a strange smell. It's often described as burning plastic or even a strange, fishy odor coming from a switch or receptacle.
A fishy smell.
Yeah, that fishy smell is actually the specific chemical off-gassing of the plastic wire insulation as it melts under the extreme heat of an arcing connection.
Wow. That is definitely a sign to call a professional immediately.
Without a doubt.
But because the physical degradation of the wire is usually so silent, the loudest alarms actually come from the paperwork.
Always the paperwork.
Right. The people whose entire job is to assess risk, so insurance companies and mortgage lenders, they treat unremediated aluminum wiring as practically radioactive.
Oh, absolutely. That mechanical issue turns into a massive financial hurdle. In hardening insurance markets, places like Florida, where carriers are already looking for reasons to drop policies to mitigate their own risk,
Right.
in those places, aluminum wiring is treated as a severe, uninsurable liability.
And this usually pops up during a 4-point inspection, doesn't it?
Yes. Insurance companies demand these for older homes to check the 4 major systems. So, the roof, the plumbing, the HVAC, and the electrical.
And if the inspector opens the electrical panel and checks the box for single-strand aluminum wiring, what happens?
Many insurers will flat out deny coverage on the spot.
Just immediately denied.
Yeah. Or, if they do offer coverage, the premiums will be astronomically high. And this applies to current homeowners too, by the way.
Wait, really? Even if you already have a policy?
Oh, yeah. If your insurance company discovers you have unmitigated aluminum wiring during, say, an inspection for an unrelated claim, they can cancel your existing policy. They might give you 30 days to fix it, or you lose your safety net entirely.
And lenders are just as strict. If you are trying to use government-backed loans, like an FHA loan through the Federal Housing Administration or a VA loan.
Oh, they hate aluminum wiring.
Yeah, they have incredibly strict safety standards. The underwriter will often condition the loan approval on the wiring being fixed before they hand over any money.
Right, if an appraiser notes scorched outlets or flags the main panel, the bank simply won't fund the mortgage until the hazard is removed.
Which leads to something the real estate guides in our sources call the disclosure trap.
Yes, the
Yeah.
disclosure trap. It is arguably the worst mistake a seller can make.
So explain how that works.
Let's say you own a 1970s home. You know you have aluminum wiring, but you've never had a single flickering light. You decide to sell, or you're applying for a new insurance policy, and you check no on the disclosure form when it asks about aluminum wiring.
You hide it thinking you're saving the deal or avoiding a premium hike.
Exactly. But an insurance policy is a legal contract of utmost good faith. Let's say a year later, an electrical fire breaks out. The fire marshal investigates and notes the presence of aluminum wiring in the remaining walls. The insurance company will look at your initial application, see that you claimed there was no aluminum wiring, and they will completely void your claim.
For material misrepresentation.
Exactly.
Meaning you were left with a burned down house, a total loss, and absolutely zero insurance payout because the paperwork was falsified.
It's devastating.
So if you are touring a beautiful mid-century modern home, how do you even know this hazard is lurking in the walls before you make an offer? I mean, you can't just rip the drywall down during an open house.
Right, but you don't need to take the walls apart. You can often see the exposed cable jackets in the attic, the unfinished basement, or right where the main cluster of wires enters the electrical panel.
And what are we looking for on those jackets?
Look closely at the printed text stamped into the plastic sheathing. If it says AL or aluminum or ACM, which stands for aluminum conductor material, you have aluminum wiring.
Okay, so seeing that AL stamp usually causes buyers to walk away. But because the CPSC data shows the actual hazard is highly localized to the connections and not the miles of wire running through the studs, the fix is actually much more manageable than most people assume.
It really is.
We can move from the panic of uninsurability to the science of permanent remediation.
Exactly. There are 3 CPSC-approved methods to deal with this, ranging from massive renovations to targeted surgical strikes.
Let's start with the big one.
The gold standard, of course, is complete copper rewiring. You physically remove the old aluminum wire and pull brand new copper wire through the entire house.
Which is a massive, highly disruptive construction project. The sources say it costs anywhere from $7,000 to over $35,000, depending on the size of the home.
Easily.
You have to tear up the drywall to get the new wires in, hire painters to patch it up, and you likely have to move out during the process. It permanently upgrades the home's value, sure, but for most buyers, tearing a newly purchased house apart isn't a realistic option.
No, it's not. And that brings us to the targeted solution, which is pigtailing.
Pigtailing?
Yeah. Remember, the danger is entirely where the bare aluminum meets the outlet.
Yeah.
Pigtailing solves this by attaching a short piece of copper wire, the pigtail, to the end of the aluminum wire.
Oh, I see.
Then you connect that new copper tip to the outlet or switch. So the outlet only ever touches copper.
It acts like a safe intermediary adapter on the end of every dangerous wire in the house.
Exactly.
Yeah.
But, and this is a huge better, but CPSC is very clear that you cannot just twist the copper and aluminum together with standard wire nets.
Right. They have 2 highly engineered methods for pigtailing. The first, and their highly preferred method, is the copalum crimp, C-O-P-A-L-U-M.
The copalum method is fascinating because it's essentially a localized metallurgical solution. You take the aluminum wire and the copper pigtail and insert them into a specialized metal sleeve.
Okay.
Then a certified electrician uses a proprietary heavy-duty power tool to crush that sleeve. It applies 10,000 pounds of pressure to the connection.
Wait, 10,000 pounds of pressure?
10,000 pounds.
Wow, that much force actually alters the metals at a molecular level, right? Creating what the engineering blogs call a cold weld.
That's exactly right. It mashes the copper and aluminum together so tightly that there is absolutely zero microscopic space for oxygen to get in.
And if oxygen can't get in, the aluminum oxide insulator can't form.
Boom! You've permanently eliminated the root cause of the risk.
That's brilliant.
It is. And compared to a $35,000 rewire, copalum usually costs about $50 to $60 per outlet. For an entire average size house, you're looking at maybe $2,500 to $6,000.
That is so much more reasonable.
Right. It's relatively affordable, it's minimally invasive since they only remove the outlet covers, and it's permanent.
The second CPSC-accepted alternative is called the Alumicon connector.
Yes, Alumicon.
So if an electrician doesn't have the proprietary copalum crimping tool, they can use these specialized little blocks instead. You slide the aluminum wire into one hole, the copper wire into another, and tighten down tiny set screws to a very specific torque.
And that block keeps the two metals entirely separate, preventing any chemical or galvanic reaction between them. The block itself is also pre-filled with a special antioxidant paste to further prevent any rust from forming.
So they are highly effective.
Very effective. Though, their bulky size can make them kind of difficult to stuff into the smaller wall boxes found in older homes.
Makes sense. Now, the sources also put a massive red flag on what not to do, because there are a lot of dangerous DIY shortcuts that homeowners try to use to save a buck.
Oh, yeah. The DIY fixes give a totally false sense of security.
And the most common mistake is buying standard twist-on wire nuts, even the special purple ones that are marketed in hardware stores as being specifically rated for aluminum to copper connections.
Do not use the purple wire nuts. The CPSC explicitly warns against those for permanent repairs.
Really? Even though they say they're for aluminum?
Yes. Extensive independent testing shows that over time, they still allow oxidation, they still overheat, and they still fail.
Good to know. And the other incomplete fix mentioned in the sources is installing CLR-rated devices.
Right, COALR. That stands for Copper Aluminum Revised. These are outlets and switches specifically designed with different metal alloys to accept bare aluminum wire directly.
But the CPSC considers CLR devices an incomplete fix because they only solve the problem at the wall outlets.
Exactly. They don't address the connections at ceiling fans, light fixtures, or junction boxes hidden up in the attic.
And you are also still relying on a direct connection to the soft aluminum wire, which means cold creep can still cause it to loosen over time.
Yep. If an insurance inspector sees purple wire nets or just COALR outlets, they will likely still reject the policy. They want to see the copolymer crimp or the Alumicon blocks installed by a licensed professional.
Which brings us to the overarching strategy for our listeners. If you are a buyer looking at a house, finding aluminum wiring isn't a reason to run.
Not at all.
It's a strategic advantage. Let's say you love the house, but the inspector finds the AL stamp on the wiring. Instead of panicking, you bring in a specialized electrician. You get a firm quote for a CPSC-approved pigtailing job.
Right. Let's say it's $4,500 for the Alumicon connectors.
Okay, so $4,500. You then go to the seller, and you don't ask them to fix it. You ask for a $4,500 credit on the purchase price.
Yes, because you do not want the seller fixing it.
Why not?
Well, sellers naturally want to do things as cheaply as possible to just close the deal. They might hire a handyman who uses those dangerous purple wire nuts.
Ah, that makes perfect sense. By taking the credit, you oversee the repair yourself immediately after closing. You ensure it's done to exact CPSC standards.
And most importantly, you are the one who receives the official certificate of remediation from the electrician.
A golden ticket.
It really is. This is a formal legal document stating that the entire home has been mitigated using CPSC-approved methods.
And that certificate is the exact piece of paper you need to hand to your insurance agent to get a standard rate policy without exorbitant premiums.
Exactly. The certificate legally shifts the liability to the licensed professional, which is exactly what the underwriter wants to see.
So you turn a terrifying fire hazard into a calculated discount. You guarantee the safety of the electrical system by overseeing the work yourself, and you satisfy the strict requirements of the insurance underwriters all in one move.
It's a win-win-win.
So what does this all mean for you, the listener? The ultimate takeaway here is that aluminum wiring is not some unpredictable ghost in the machine. It is a well-documented, highly understood mechanical issue.
Yeah, it's just mechanics.
And we have a permanent, scientifically proven engineering solution for it. It absolutely demands your respect. You cannot ignore it. But it does not demand your fear.
Well said. And, connecting this to the broader real estate market raises an important final thought.
Oh, what's that?
Well, think about it. Over 2 million homes were built with this material between 1965 and the mid-70s. Standard home inspections often just spot check a few visible outlets by popping off 1 or 2 plastic covers.
Right.
So think about how many modern, beautifully flipped 1970s homes are out there right now. First come in, they tear out the old cabinets, put up pristine new drywall, sleek subway tile, luxury vinyl plank floors.
Oh, wow. I see where you're going with this. Did they actually spend the $5,000 to properly remediate the wiring behind those newly painted walls?
Or did they just slap shiny new smart outlets onto the old oxidizing aluminum wires and bury the problem entirely?
That is a terrifying thought.
Right. How many freshly renovated mid-century modern homes have simply buried a ticking time bomb behind beautiful aesthetics? The next time you walk into a flipped house and admire the waterfall kitchen island, remember to look past the surface.
A beautiful exterior doesn't mean a safe interior. Look for the AL on the exposed cables. Ask for the certificate of remediation. Respect the risk, negotiate the fix, and sleep soundly knowing the science is on your side. That's That's our deep dive for today. Keep questioning what's behind the drywall.